Joshua Arvin Lat from the Philippines on stage. He's a Chief Technology Officer at Nuworks Interactive Labs. He previously served as a CTO for 3 Australian-owned companies and startups. He is an AWS machine learning hero and has spearheaded and led the machine learning 0 to 0 online international event, wow, years ago. He and his team won first place in a global cybersecurity competition with their published research paper on secure two-factor authentication systems. He's also the author of Machine Learning and Machine Learning Engineering book to be out in 2021, so keep your eyes open. And now please welcome on stage our next presenter, Joshua Arvin Lat, with his presentation, Designing and Building Complex Machine Learning Projects and Workflows, Serverless and Containers. Joshua, the stage is yours.
So again, thank you for that. Thank you for the opportunity to share this talk for everyone. So I'll make sure that I get to discuss this properly, and also I am able to discuss this in the shortest time possible. Yeah, so there will be a lot of things that we'll learn in this talk, and I'm going to make the most out of the time available to discuss all the needed things that you may not know also, which will be very helpful in the future. So let's properly start this. So the topic for today would be designing and building complex machine learning projects and workflows, serverless and containers. So you will see that we will talk about machine learning. We'll talk about machine learning workflows, automation, and how do we use serverless and container technology to support that in a very practical way. So I will be sharing my experience this past couple of years experimenting and deploying these things in production. And yeah, the good thing there is that I'm able to extract what's really practical and what's useful in our day-to-day lives. So to quickly introduce myself, I am Joshua Arvin Lat. People call me Arbs. So again, I am the Chief Technology Officer of Nuworks Interactive Labs. I am also an AWS machine learning hero. And if you look at the screen, you can see that there's a mug there. I actually got that mug when I participated several times when trying to update the AWS Certified Machine Learning Specialty exam. So I was invited years ago, and then I contribute to some of the questions there. So if ever that you take that exam, probably some of the questions there are from me. So I got that mug as a gift. And then I'm also the author of a machine learning and machine learning engineering book called Amazon SageMaker Cookbook. So it will be released, I think, 1 month from now. So stay tuned. So there, you will learn a lot of things also, like let's say how to do machine learning and machine learning engineering with just a couple of lines of code, how to do customization, how to use Python and R, along with the different utilities and services and capabilities of Amazon SageMaker. Of course, Amazon SageMaker, if you haven't heard about it, it is the machine learning platform from AWS where there's a lot of capabilities and features there, which is being used by a lot of people in their production projects. So enough about myself. The goal now is for us to talk about the topic in hand. So, okay, let's make this quick because, of course, it's very important for me to introduce the concepts. So machine learning, serverless, and then containers. Those are the 3 important things that we need to quickly describe over the next 2 to 3 minutes. So what is machine learning? Machine learning is simply about trying to do something which is not explicitly programmed. So we can keep it at that. And a good example of that would be, let's say, identifying if this picture of a cat is either a cat or not a cat. So if we were to compute something with a program, let's say 1 + 1, you may get 2, the value of 2. So with that one, you can technically explicitly program it to do it like that. But once you have to deal with something that's relatively trickier to perform with a machine, you may be able to use machine learning for that one. So for example, if you had 10,000 images of cats, each with different angles, each with different variations, and you feed that into an algorithm, and that algorithm produces a model using this trained data, and your model generalizes over that trained data, you would be able to have a model that may accurately predict, more or less, if the new image is a cat or not a cat. So that more or less is a simplified introduction or explanation on what machine learning is. But what we can say is that machine learning is cool and machine learning is powerful. But trying to deploy these workflows and projects in productions, it's not as easy as it sounds. So if you were to try it out in your local machine, then okay, yeah, you are able to get that experiment to work. But once you have to scale that project across different team members, or you have to share that and you have to work with different people, you have to also take into account the models that you have to deal with. Maybe instead of a small computer, you may need a larger computer or a larger server to work on your requirements, especially for, let's say, NLP applications. Then of course, you may need to do a bit more research and upgrade on your tooling and platform that you're using. Next, serverless. So what is serverless? Years ago, there was a time when serverless was confused with function as a service. So of course, those two things are different. If you have heard about AWS Lambda, for example, where you can just write a bit of code and then that function would perform an action, that is called function as a service. So that's not equivalent to serverless. So what is serverless? Serverless means that you're able to do something without having to worry about servers. So let's say that I want to launch an application, and instead of me having to worry about the system administration part, patching, I don't need to worry about manually scaling the back end and so on. And if I want the price and cost to be scalable while the application is being used, then that's serverless. Of course, there's a more specific or more complete definition of serverless, but that's a more accurate way of describing it, as long as you don't confuse it with function as a service. So this is one example. So 5 years ago, or was it 6? So 5 or 6 years ago, I decided to implement this in my company where we had a lot of servers running in our AWS account. So instead of me trying to create another server just to detect and compute the cost per day at that time, all I needed was to use several services which had its own purpose. And each service was more or less free as long as it's inside a certain set of bounds. So there's something called free tier. So what this system does is every, let's say, 12 hours, it computes, it checks all the running servers, and then it sends an email to the developers, especially if the developers have forgotten to turn off the servers. So before, there wasn't much automation options when it comes to turning off the server, so we had to do it manually. So this would serve as a reminder. And then the cool thing here is that this system doesn't have any downtime options. So meaning that this system is always up. That's the first key thing here. The second one here is that the cost scales as the usage increases. But since that this is just used about once or twice per day, literally just 4 seconds. So 1 to 2 seconds for the first request, 12 o'clock. And then that's 2 seconds. And then another 2 seconds for the additional after 12 hours. So more or less, we weren't paying for anything for this one. And we were able to utilize the serverless concepts and techniques to help us add some automation with our systems. So that basically is one of the advantages of serverless computing. So later, we will see how this combines with machine learning engineering and containers. Containers, on the other hand, if you have used something like Kubernetes, here, you can see that we can organize things. We can actually use different programming languages inside different containers. Technically in Kubernetes, there's something called pods and containers. But to keep it simple, let's just think of containers as um, containers where you have an isolated process that you would like to contain. And if something goes wrong with that process, you can just automatically replace it with a clone with the same template, same setup, which makes things more predictable and scalable as well. So the advantage of using containers is that if you're working something on your local machine, it would most likely work in your staging and production environments. And all you have to do is, let's say, use an orchestration tool to manage your containers in production. So the advantage when using containers is that, especially if you're working on a lot of projects, containers do make it easy for everyone to keep things predictable, whether it's just single developer or single engineer. And if you have to pass it to some other system, then at least the assumptions are still going to work, even if you've passed things around. So there's minimal or less problems when it comes to installation and setup. All right, so let's now talk about machine learning engineering. So here, we can say that it's machine learning plus engineering, which is more or less the case. Maybe you may think about it as somewhere along the lines of ML ops or something. But what's important here is that if we are, let's say, working on an experiment, it's also important for us to know that the way we build things may not necessarily be the same as how we work on our experiments. So let's say that there's a data scientist and then there's an engineer. Those two roles or individuals would have skill sets that are common to both of them. But there will also be capabilities which would be different. So let's say a data scientist would be good in experimentation, presentation, and proof of concept. But the implementation may not necessarily be something that can automatically be deployed to production right away, meaning that you still have to modify the code a bit to make it production ready, at least from an engineering standpoint. And then when you're an engineer, you have to worry about, let's say, auto scaling, you have to worry about high availability and resilience, and all the other things in that area. So now, the goal now is for us to be able to have a smooth workflow when talking about machine learning and engineering. And right now, being a machine learning engineer requires a lot of things. You have to know a bit of data science, you have to know about machine learning, about engineering, DevOps, and so on. And being able to know what really works in real life or in production may not necessarily be found in blogs or even in advice where you can get them online. So being able to experience this yourself, you would realize that, okay, it seems easy, but it's not really as easy as it sounds. So the goal here is for us to understand what really works and what doesn't work in production. So number one, so let's talk about the most important thing. After dealing with all the projects and all the requirements over the past 10 years, I realized that the most important thing, or one of the most important things, would always be time. Time would always be precious. Let's say in machine learning or machine learning engineering terms, let's say you have a machine learning model that you want to train. And there are, let's say, 4 or 5 members of the team, maybe 1 data scientist, 2 machine learning engineers, 1 manager, and then let's say 1 person doing the documentation or something. If your project lasts for about 3 weeks, you have to worry about the salary of those people for 3 weeks. And of course, the output of those the output of that team needs to be more than what you're paying them, right? So of course, from a business standpoint, this is important. And you have to be aware that the faster it takes to deploy something into production, the better, without having to affect the quality. So time is always important because even if you have the best model out there, if you're not able to release in time, you will lose money just because of the delays. Also, in addition to this one, if you have a competitor, if your competitor can complete something in 2 weeks while it took you 2 months to complete something, then your competitor would have the opportunity to experiment and check their product and release their product to the public way ahead of you, and you will lose that advantage. So time is something that's critical, and that's something that you need to protect and take into account. The next one would be logs and events. When you're dealing with an engineering project or even a development project, usually people are afraid of errors. People are afraid of mistakes. But if you look at, let's say, veteran developers, let's say that they're both dealing with a new technology or a new language, sometimes the veteran developer or veteran engineer would more or less have the same pace, and they might make the same set of mistakes as with a beginner or junior developer or engineer. So what makes those two different? One of the major difference would be that the veteran developer or engineer would not panic, because if there's an error, the engineer would simply just, okay, there's an error. What would I need to check and what would I need to tweak in order for me to fix the problems? And you will be able to fix the problems if there are logs. So one common mistake that companies do is that, okay, let's try to save money and let's turn off the logs. But how would you be able to debug something if there are no logs, if there are no symptoms? So it's better if we are able to debug things with logs and events. So if there's something like an alarm or something, that would be very useful in debugging things properly. So logs are very important, and events also. Let's say that you're using Python in your company when dealing with machine learning experiments and projects. It's important to enforce rules, but it's also important to be very, very practical about it. Sometimes when you become part of the management team, sometimes you will have that mindset, okay, rules are very important. We have to enforce things. Standards are very important. But sometimes if you try to be too rigid about it, and if you have 100 rules that you would like to enforce your entire team, then most likely you won't be able to execute that properly. Because for one thing, there are too many rules, and two, people won't be able to focus on their jobs. So what's important here is that there's just a limited set of rules that you would like to enforce, especially if you're just starting things out. Maybe 4 to 5 rules may be sufficient in getting this to work. So for one thing, let's say 20-line rule, maximum of 20 lines in a single function. Maybe following the PEP 8 guidelines, avoidance of try-catch blocks to make sure that there's no hidden errors disappearing in the logs. And then finally, writing testable Python code. So of course, if you're using a different language, feel free to look for the counterparts on what's shared in the screen. The next thing would be utilizing continuous integration and deployment pipelines. The advantage here is that, one, it makes things more predictable, and two, it enforces a certain process, especially when different team members are working together. So now, during the pandemic, you would probably appreciate that the usage of automation and the usage of more or less a more rigid set of processes would help the team make more predictable outcomes. So here, let's say you have custom Python code, and then you have a model. If you have something launched already in production, you do not want that system to fail just because of unplanned or mismanaged deployment. So what you want to do here is that after you push code, that code would automatically be packaged and then tested. And then before deploying it into production, maybe there's some manual approval first, and then there's like blue-green deployment happening there. So the advantage there is that you won't have to worry about the end deployed product or the end deployed model, because there's an automated system that helps you ensure that things are being tested properly, as long as this entire system is being used properly by the team. So as early as the beginning or at the start of the project, especially if the project would last, let's say 3 to 6 months, this is a really good idea for teams. The next one would be about making the most out of machine learning frameworks and machine learning platforms. Not everyone would probably agree with what I will say here, but from experience, I did experience something like this where I had to choose whether to build something from scratch or to use something that's already existing. So from my end, as you are aware, I am a fan of building something from scratch because I can practice my engineering skills and capabilities. But over time, I started to realize that making the most out of existing tools and frameworks, let's say PyTorch, TensorFlow, MXNet, and SageMaker, instead of me trying to build something from scratch, maybe trying to utilize something that's already prepared by someone else and being used by a lot of people, it may actually make more sense in most cases, especially when you're dealing with a team. The problem when one member of your team builds something from scratch and that person resigns, there's no guarantee that that the remaining people will be able to use the same code base properly. But if you use something that's already available, and also those tools already have a lot of things configured already, you won't have to build something for like 3 months to 6 months if something is already available within just 1 to 2 days. So learning things within 3 days to 4 days is definitely worth it instead of like building everything from scratch for like 3 to 4 months. Of course, that may not necessarily hold true, especially if something that you'll be building from scratch is just a small piece of work or something that really fits your needs. So here, let's say that if we were to use SageMaker, we would be able to abstract the infrastructure part. So before, you may need to code separately how many instances you want to launch, how many instances you would like for the inference endpoint, how many instances you would like for bias detection. But if you were to use something like SageMaker and then you made the most out of the software development kit available, you would probably be surprised that with 5 to 6 lines of code, you would be able to provide proof of concept work already. So this is very powerful because it solves the two problems where you need to provide quick POC work to prove to your boss that your idea is feasible. And then the second part, once you have the budget, you would be able to easily use that tool to evolve it into something that's customized to what you need and something that can easily scale and easily be deployed into production. So the advantage there is that it works for proof of concept work, and then you would be able to get it to work live. So here, another skill that's very important is being able to customize what's available out there. Because sometimes the limitation or constraints when using something that's existing is sometimes that it's not that flexible to use. So maybe that when you're using a tool, there's a certain set of constraints. So a very important skill that your team needs to have is the ability to use an existing tool and at the same time being able to configure and maximize those tools and get it to work depending on your use case. So being able to debug things, being able to bring things together, that's very important. So here, what we can see here is that, let's say you have a serverless API endpoint where you have an API gateway receiving the request. And then you're using Lambda, you're triggering a Lambda function to perform the prediction. So here, in scenario number 1, you have scikit-learn installed inside Lambda. In the second case, you have TensorFlow installed in Lambda. And that in the third case, you have Facebook Prophet inside AWS Lambda. So if you were to use models using those tools, libraries, or frameworks, you would be able to use AWS Lambda. And if it's not being called that many times per day, you might even get the system for free. That's the advantage of being able to maximize something that's serverless and something that makes use of existing tools and frameworks. So a good solutions architect would be able to provides a solution like this, because this may not necessarily be available in the documentation, but you can bring things together to get something to work. All right, now let's discuss the different options available, some of the options available when talking about engineering solutions. So let's say that you have a machine learning model. What can you do with that? The first one is the model is deployed inside an EC2 instance. The second one would be deploying the model inside a container, a Docker container inside an EC2 instance. So you wrap the model, wrap the process, let's say Flask, inside a Docker container, and then run it inside an EC2 instance. It's also possible to have to use the built-in algorithms of SageMaker, and then just with one line of code, estimator.deploy, you would be able to deploy that model into an inference endpoint with a single line of code because there's an SDK to automate the things. And then you can also have your own custom container and use your own custom container image with your model inside it and deploy it into a SageMaker endpoint. The advantage there is that SageMaker has a lot of capabilities, let's say model monitor, where you can detect if there's, let's say, bias drift or if there's data quality drift. You can automatically detect that because the hosting services already provide that. So if you're using other platforms, try to look for similar solutions where you don't have to code much, but the tool already provides support for a lot of those. Here, with a model deployed inside a Lambda function, this is what I showed earlier, where you can make the most out of serverless strategies with a bit of customization. And it's also possible for a Lambda function to trigger an endpoint. And then with API gateway mapping templates, no need for us to even prepare a Lambda function. And then finally, deploy a model inside Fargate using containers. So using containers and serverless technologies, there are a lot of options available for us. And this really depends on the tech stack of the team using it. So there are also other options here. We will not dive deep into what's available here. But what I can say here is that if you were to use, let's say, a tool, let's say like SageMaker, there's a lot of options there, like multi-model, multi-container endpoint, and even set up A/B testing, where one model would get 80% of the traffic, and then another model would get 20% of the traffic. And then you can compare which one is performing better. And if model B is performing better than model A, then you shift all the traffic to model B. And then finally, you can also deploy a model using Lambda function and containers. So basically, you combine serverless and containers in a single solution. So here, there's also something called automated workflows. So with automated workflows, we can divide the steps and different parts of the machine learning process and make it easily modifiable, auditable, and easily reusable. So here, we combine step functions and then SageMaker, and then we use the data science SDK to prepare something like this. So the advantage here is that once you are done developing an automated workflow, if let's say you want to perform model retraining, you can use this approach where you just push in the new data and then you have a new model, you check if that model is performing better than the current one, and then replace the model automatically. The advantage there is that there's less or no manual work required from your engineers when you have new data to produce a new model. So that's pretty cool, especially if you are able to do something like this. So again, check step functions and SageMaker and the data science SDK. So here, we can also automate bias detection. Of course, with SageMaker and SageMaker Clarify, what you can do here is, let's say, just pass in the data, maybe pass in the model, and then you can detect the pre-training or post-training bias. So examples of bias would be class imbalance or even DPPL, or maybe treatment equality. The advantage here is that even if you're not familiar with all these formulas, as long as you run this process, you would get a set of scores and metrics. And as long as you know how to interpret that, you would have the ability to talk to your data scientist and tell them, okay, this data set is suffering from class imbalance issues. Hope we can fix them so that the model would not be as biased as how it is right now. Yeah, so take a look at this, as this is a very important topic when deploying something into production. So here we can see a couple of lines of code. And this is just about initializing some objects to configure your SageMaker Clarify job, where that helps you predict things and helps you compute the bias metrics. And this is a sample output where, okay, this is the context, these are the thresholds, and these are the class imbalance scores. So given that the score is near 1, then there's definitely a class imbalance problem in your dataset. The same way here, we want to enable machine learning explainability, where you want to know which features actually contribute to the final outcome. So here, you don't need to learn and install all these libraries with just a few lines of code. you would be able to automate and get a quick report like this one. So how do you interpret this? So you have feature 1 and feature 0, basically the first two features contributing to the final outcome of the prediction. And then the last two features, feature 2 and feature 3, they don't contribute as much. So most likely the values in these columns are probably random. So here's a quick report. So it just happened that it looked like this, but you'll just get numbers like this when you run an ML explainability job. So we're near towards the end. What we want to include here is that when you're also trying to run automated hyperparameter tuning jobs, this means that by tweaking the hyperparameters of your machine learning training job, you would be able to come up with different sorts of models with varying performance metric scores. So in order for us to come up with a better model, we need to experiment and test different hyperparameters. Using cloud computing techniques, we would be able to run multiple training jobs using different hyperparameter configurations, and then whatever model which has the best result, we get that. And we can technically even use this as part of the AutoML pipeline, where you just pass in data, and then the AutoML pipeline would just automate everything from feature processing of feature stuff, and then after that, you transform it a bit, and then you perform hyperparameter tuning, and then finally doing some ML explainability work before trying to deploy the model to an endpoint. So here, the advantage here is that we can make the most out of transient ML instances to train our models. The advantage here is that you don't pay for the cost when it's not running. So let's say that you have a notebook and you have a large data set. Instead of us having to have a large notebook where we run all our experiments, we can run our experiments inside an isolated transient ML instance. So if we're talking about, let's say, Hugging Face models, that one would require a really large instance. What you can do there is that have your data stored in a storage and have a really large transient ML instance running for about 3 minutes. And then the advantage there is that if you need a large instance, there you go. If you need a smaller instance, there you go as well. So you can play around and tweak this depending on the budget that you have also. So finally, for security, we need to practice the principle of least privilege. One, in account setup. So ideally, when you set up your accounts, when you have people using your systems, it's important for us to practice principle of least privilege. What we want to do here is that if one of your systems get compromised or something, we can also use the same techniques to limit the damage done by an attack in our system. So yeah, that's pretty much it. It contained a lot of things, but definitely you can use 3 to 4 or 5 of those to help you with your day-to-day lives as data scientists and machine learning engineers. So thank you again, and feel free to reach out to me here. There's my email and there's my LinkedIn page. So thank you again and have a great day ahead.
Thank you very much, Joshua. And now we will start the Q&A session. And I would like to encourage you all to post your questions under the Q&A. And I have a new information that if you do so, you will have chance to be in a ballot where you can win a Google Nest speaker, which is really great. So go for it, guys. So shoot your questions. We will have chit chat with Joshua, and you can go for that. So first of all, Joshua, before the questions are popping in, I would like to ask you about what about best practices? So can you share a few best practices with us?
Okay. Thank you for that. All right. So in terms of best practices, given that I've shared a lot of things here, I think that most people are probably leaning towards the more technical end of things. What I mean is that despite everything I've shared here, the most important thing when talking about best practices and applying all of these things, all of these solutions in real life would be first listening to the customers, listening to what the clients need. So that's the number one best practice, because sometimes people tend to go straight to implementation without thinking about the needs of the customer or client. Maybe you don't need a really high-tech solution to solve your client's needs. Maybe a solution that's out of the box, that's something that you can just use without having to build anything. That may be the solution. But so listening to the needs of the customers, that's number one best practice. And then second, being able to adjust if there are blockers. That's the second most important skill that we all need, because things do not go according to plan most of the time. So being able to have plan A and then plan B and making the most out of the solutions that I've shared in those plans would definitely help people get things to succeed, especially when rolling things out into production. So yeah.
Thanks a lot for your answer. My second question would be from Alexandra. Do you specifically suggest SageMaker, or that is what you used the most?
Yes, good question. From my end, given that I'm very familiar with SageMaker, so as you can see here, I wrote this book. Initially, I thought that SageMaker was just about built-in algorithms. I thought it was just about having a notebook instance where you can run your scripts. I didn't know that there was a lot in there. As in, you have debugger, you have pipelines, you have model monitor, and one book is definitely not enough to discuss all of those. And if you're using AWS already in your company, then use SageMaker. So instead of you trying to build something using the EC2 servers and trying to build your own machine learning platform, a good option would be SageMaker, because this one keeps on evolving every month or every 2 months. You will see that, okay, there are new features there. And AWS is really investing a lot of time to upgrade this, to make this the best platform available. But if you're using another platform, then feel free to do so. What's important there is that you're able to maximize what's available in that platform. If you're using Azure, if you're using GCP, then go for it. What's important there is that you do some research first. You compare the different platforms, check how much it costs to use a certain capability of a service, then use it properly. And then let your team use that properly as well. Because from your end, you may be the subject matter expert, but if you do not enforce standards, your other team members may end up misusing a certain tool. But yeah, from my end, I would definitely recommend SageMaker, because for one thing, I've used it multiple times. And here, yeah, upon writing the book, I realized that, wow, it's super powerful. And a lot of things are not even documented properly. So that's why when I wrote the book, I realized, okay, I would use the book myself because it's documented there, step by step. And then if I forget something, I'll just use this as reference. But thank you for that question.
Thank you for the great answer. And there is a Jolly Joker. How you got recommended? Okay, have you guys recommendations for machine learning beginners, like books, services, etc.?
Yes, thank you for that. That's a really good question. Basically, the question is recommendations on how to get started with machine learning. The first one would definitely be, trying to look for free options first. That's the first thing. Usually, the tendency is for us to look for paid options. There's a lot of references and tutorials in YouTube. There are a lot of free books out there. There are a lot of references in blog posts. You can start with that. It's more about technique. When I say technique, sometimes people just want to keep on reading. People just want to keep on reading books. Reading books is important, but having to have a proper balance between concepts and hands-on, that's the second part there. After reading a certain blog post, try it out. Install the tools in your machine, install Python, run a couple of examples. Try the simple examples first. And then the next step there, which is usually not shared in blog posts, try to generate your own data sets. So that's the secret. The secret there is that sometimes you will be overwhelmed with the available data sets, especially the real life data sets available out there. So sometimes the data sets will not work right away, or maybe that data set will have 30 columns and no explanation is available on how to interpret those columns or fields.
But if you have generated your own data set, let's say just 3 columns, a name, column A, and then column B, and you would use, let's say, XGBoost to perform a simple prediction by trying to predict the value B using the value A, then that would be a good start. And then start experimenting with different models, because the second part there would be, the question is, okay, do I try to master one machine learning algorithm, or do I try to learn a lot of them? My suggestion is for you to try a lot first. And then when you encounter a specific project or a real project, that's the time you master or be an intermediate user of a certain algorithm. Yeah, so basically that's my advice. Basically, read and learn, apply. Read, learn, and apply. That's the cycle. And you can do a lot of things for free. And there's a lot of available books out there, and you don't need to spend as much, especially when you're getting things started. But yeah, thank you for that question.
Thanks a lot for your answer again. We have two more minutes for the questions, and first I want to ask about the Dockers. So how about the Kubernetes or plain Dockers you prefer? And yeah, this is a question in general.
Thank you for that. So I have used different variations of container solutions. Kubernetes, Docker, Docker Compose, ECS, EKS, all of these things in production. I've even used this when it was in early stages. My recommendation is Docker and Kubernetes, they're not competitors. Okay, you can use, because Docker is used in Kubernetes. What's important here is that you use Docker to prepare your container images, and then the next option would be, what do I need in my production environment? Do I need a workflow container or a workflow orchestration tool like Kubernetes to handle my requirements? Usually, if you're dealing with a relatively complex application where you have, let's say, 4 servers or 8 servers, it's a more or less medium to large application in production, then yes, you can check Kubernetes. But if you just have 1 server and it's not as complex as it seems, and it's just in the first 2 to 3 months of your project, then maybe trying to use something that's a bit simpler would work for you. So use something like Fargate or ECS or maybe Docker Compose. That may do the trick. What's important there is that you understand how containers are properly used, because it's not similar to how you use servers. Servers, you can take care of them, but with containers, you basically throw them away if they're no longer working, and then you just replace them with a clone of that container. So understanding the concepts is way more important than choosing the tool at this stage. Yeah, thank you for that answer. A question.
Thank you very much, and thank you very much all for the questions. Now